So we need to get the facts straight. How does this virus work? How does it transmit? Where does it want to go? And let's protect ourselves. I'm Dr. Peter Lin. I'm a family physician in Toronto, Canada. The coronavirus is a family of viruses that can cause as mild things as just a common cold, all the way up to SARS or MERS. These are these bad pneumonias that we're talking about. And basically what these viruses are, they look like a tennis ball with all these spikes sticking out of it. And depending on the type of spike, it allows that virus to attach to certain places. So some viruses, they have the spike that attaches to your nose. So basically you just get a common cold. But the SARS virus and this new virus that we're talking about has the spike that allows it to attach to the cells in your lung. And when it attaches there, it puts in information to make photocopies of itself. So it uses our equipment to make more viruses.
I'm declaring a public health emergency of international concern over the global outbreak of novel coronavirus.
Most of the coronaviruses live in animals. In this particular case, it was from Wuhan. There was a fish market where they were selling live animals. And the thought is that the virus was in a live animal, then it crossed into a human. But then what we found was that people were getting sick in terms of healthcare workers, in terms of family members that were looking after them, which now meant that the virus can pass from human to another human. Just like all viruses, it needs to reach a target, which is your lung. And it has to get there with your help. It has no feet and no wings. So therefore it needs us to move it there. So that's why we keep saying, don't hang around sneezy people because you're gonna breathe it in, and don't touch your face because that's how the virus is gonna get in. The masks are helpful, but they're not necessary because they're leaky. The ones that you and I buy basically have pockets here, so therefore the virus can get in. What the masks really do is they stop us from touching our face. If you're sick, we tend to mask you, so therefore you're not spewing out the viruses to other people sitting around you. The true people that have the real masks are the N95. Those are sealed. These are for the doctors that may be caring for the patients. So in the beginning, the coronavirus will cause kind of like flu-like symptoms or a cold. So people just get the stuffy nose, that kind of thing. But you'll understand that as soon as that virus starts manufacturing in your lung cells, they're producing all these copies of the virus, all of a sudden now you kill the lung cells. So now you can't exchange oxygen, and that's why one of the early symptoms is people get very short of breath and they tend to have a difficult time breathing, and that's why they end up in hospital. So currently, unfortunately, we don't have a direct treatment for the coronavirus. So we don't have a medication that can kill it off. And so it's really supportive. So in other words, the patient can't breathe, we give them oxygen, help them to breathe. They can't drink, so therefore we give them fluids to support them. Their kidneys begin to shut down, we help them with all those things. So it's a very supportive process. This is a new virus that we've never seen before. So our immune system, our army, are having a hard time figuring out what to do. So usually what we have to do is we make something called antibodies. So these are things that can grab onto the spikes that we see on the virus, and it'll get rid of the virus for you, and that will actually bring you back to good health. So therefore the elderly may have a worse outcome, and of course the young children. So the babies, their immune system is not so good either, so they may not make those antibodies as well. So just remember, your hands may be with virus. Virus cannot hurt you because it can't get through the skin, but the moment I do this, now I've brought the virus right to where it wants to go. So let's remember not to touch our hands to our face. So let's say you think that you might have been on a plane or you might have bumped into somebody that has it. What should you do? So the first thing is to contact a healthcare worker to tell them that potentially you have it. If you're feeling symptoms and you're going to go into a facility, call ahead. Okay, so whether you're calling the paramedics or whether you're calling the hospital or your doctor, just mention that you were on a flight. If you don't have any symptoms, then what we do is a little bit of a self-quarantine. In other words, we can just keep you away from other people, and so you don't go into parties, don't go with your friends, don't go into public transportation. So we can contain it very easily by making sure that you do a self-confinement, so to speak, for the, let's say, 7 to 14 days is the longest incubation time. So after that, if you're feeling well, then you don't have anything to worry about. So if we get the facts right, then we don't have to be overly worried, but we do the right things so that we don't get the virus ourselves and that we don't pass it on to others. And if we look after each other in this way, this virus will have nowhere to go. It needs us to move it, it needs us to make copies for it, and if we don't help it, then the virus will stop. So we have the power to do that right now.
slow. I'm not feeling too well since I got back from China. But by the way, how many of you have been infected with coronavirus? About 10, 12 of you? All right, remember that answer. Because the reality is all of you have that. Well, I'm going to talk a little bit about what we know about this novel coronavirus, understand where and how these novel viruses arise, describe what infection of humans looks like, and briefly talk about some of the public health approaches, the antiviral and vaccine approaches to this. I'm going to start with a quote from Albert Camus, who said, "They fancied themselves free, and no one will ever be free so long as there are pestilences." And particularly for looking at the resident physicians here, particularly in your career, you've seen this. And so let me just ask another question. How many of you believe that in your professional lifetime that you're going to see a significant pandemic? So it's interesting that a lot of hands go up. When I gave grand rounds in 2000, I think it was, at Mayo Clinic, I asked that question. There were about 600 physicians in attendance, and 5 people raised their hand. And that's been a constant in human behavior, that we really don't believe that these things are going to happen. Just remember, and it's odd to say it, but in the end, the bugs win, right, Sandra? All right. So for those of you where this is really early and the coffee's not yet strong enough, here's the summary, then you can go to sleep. This is a rapidly evolving situation with the potential for significant morbidity and mortality in humans. And I'll elaborate. All right, now remember that in order for a virus to be pandemic, 3 criteria have to be in place. It has to efficiently infect humans, it has to replicate in humans, and it has to be able to spread easily, that is, transmit easily among humans. How well this novel virus fulfills those criteria is not yet completely known. So, one of the issues that we've had, certainly in my career, maybe some of you know this virus, 15 million people were infected, 140,000 hospitalizations, 8,000 deaths, and 54 deaths in children. Anybody know what that is? That's influenza this year. So keep those numbers in perspective. We have a difficult time nationwide getting healthcare providers to get their flu vaccine. Imagine if I said that we, today at NCH, we're the first ones in the nation to offer coronavirus vaccine. We would be trampled with people trying to get that vaccine, and yet a far greater problem when we can't get people to get immunized against flu. All right. Well, there are 7 coronaviruses that infect humans. The 4 that you see listed up there, all discovered since the 1960s, are for the most part benign. Mostly upper airway type illness. It's about 30% of seasonal upper respiratory infections. These are endemic, so they circulate all year long. And generally, except for certain patient subpopulations, not much of a big problem. You remember SARS not too long ago in 2002. There were 8,000 known infections. And by the way, when you see these numbers, they are guesstimates. This is what's known. But this is, sort of like the tip of the iceberg. What nobody knows is how many asymptomatic or mild infections occurred that never sought any kind of health care, were never tested, etc. Now, it's interesting because, as you'll learn this morning, the virus that we're dealing with this morning is SARS-like in its pathophysiology and in its virology and immunology. So about 8,000 known infections. The peak viral shedding tended to occur about 10 days after symptoms. Remember that number. And there were definitely identified super spreaders, that is, people who infected as many as 128 other people. What's called an R naught of greater than 0. And we're going to talk about what that means too. About a 10% case fatality rate, 20 to 30% had severe disease, required mechanical ventilation. The receptor for this is very interesting. It's the angiotensin converting enzyme. Odd to even think of that as a viral receptor, and yet it is. This is in contrast to MERS, which had far less infections, a higher case fatality rate, used a different receptor, but also had super spreaders. Now, SARS, as you know, is controlled. How was it controlled? There was no antiviral, there was no vaccine. Good, old-fashioned, washing hands, wearing masks, isolation of cases. It works. It's low-tech, it's not sexy, but it actually works. MERS, by contrast, continues to smolder along. There's been sporadic transmission, very limited human transmission, fortunately. The reservoir appeared to be bats, with the intermediary host being camels. All right, what about this new virus? Well, it's called 2019 novel coronavirus. It's identified in Wuhan, China. Corona simply refers not to the beer, but to these spikes that are said to be crown-like on the virus. Now, the issue with coronavirus is their extensive ecological diversity. I mean, you can find them in virtually every animal species. The greatest variety, at least as best we know, is in bats, and they seem to be the major reservoir for this. So actually don't go into bat caves and things like that. It's not a good idea. Now, this happens to be for MERS, but it was a good illustration. I thought I'd use it of just how does this happen? Well, as I'm going to show you, and I've been to the wet markets in China, these are ideal petri dishes for the development and the homologous recombination of genetic material. So as I said, the greatest diversity is in bats. They have saliva, they excrete, they have birth products, etc. This falls into plants, into water, on the ground. These animals walk through it, eat it, etc. And then, of course, we're exposed in various ways to these animals. When I was in Beijing, you could go to a wet market and buy animal products from everything here, although I did not see alpaca, but virtually everything else. And things you would never think to eat, you can buy, people eat there. And that's a problem. Now, there are alpha, beta, gamma, and delta genera of coronavirus. What we're going to focus on this morning are the beta coronaviruses. As I mentioned before, some of these are pretty benign, but others of them, like MERS and SARS, had not been benign infections. Now, there's been preliminary work already published. It's amazing. It took months and months to do this with SARS and MERS. This happened within a week or so with this virus. But at least when full-length genomic sequences have been looked at, and they've sequenced over 5 now, they're essentially identical to each other. So at this early stage, there doesn't seem to be viral evolution and mutation. They seem to be well adapted. And they share about 80% sequence identity to SARS, so very SARS-like in its genetics. So the point I'm trying to make here is that fundamentally, this is a zoonosis. So this is transmission of a virus across the species barrier into human hosts. All right, how does this virus actually infect humans? Well, multiple ways, and they're not ways that are unfamiliar to you. Certainly inhalation of viral-laden respiratory droplets, touching contaminated surfaces, close contact, and maybe eating infected and not properly cooked animal material. And I'll show you some examples of that. Here's the key event that occurred. Are you ready? Drum roll, please. This is a cartoon of what the coronavirus looks like. This is a positive sense, single-stranded RNA virus. I mention that only because it's important. A positive sense, single-strand RNA, genetic material. It acts like messenger RNA and can be directly translated into viral proteins. So you see the major surface-borne proteins, the S protein, the nucleocapsid protein, membrane protein, and envelope protein. This appears to be the most important part, this S protein or S spike, and most all of the vaccines and antiviral therapies are being focused on S. So how does this work? S is actually a trimer of S1 and S2 proteins. It is, if you think of it sort of like a lock and a key, this protein trimer complex binds with this receptor, which in the case of this novel virus, as I mentioned, is ACE2, and then gets into the host cell and can begin translating right away these viral proteins. So for some people, this becomes overwhelming viral infection. They develop ARDS, multiple organ failure, and there's, other than supportive care, there's really not much to do. The important part is that of this S protein, the globular head called S1 is composed of 3 pieces. And this is what the crystal structure looks like of this trimer. Here's 1, here's 2, here's 3. Everything you see in gray is what the amino acid residues of SARS S1 look like. What you see in red are the differences compared to this novel virus. So you see that it's surprisingly different from the SARS S1, and yet is acting pretty much identical. That's good, because we can leverage everything that we learned from almost 2 decades ago with SARS into rapidly developing antivirals and hopefully vaccines for this novel virus. All right, what's the importance of this receptor? Why am I yammering away on that? Well, one, because it interests me, and frankly, you're a captive audience at this point. 2, there actually is some importance to it. One is the anatomic density of these receptors. So the coronaviruses that you've all been infected with, those are viruses adapted to upper airway respiratory epithelial cells. They are not well adapted to the higher temperature, lower respiratory. So they're more nuisance infections, again, except for immunocompromised and young children, etc. The ACE2 receptor that I mentioned to you is much higher density in the lower respiratory tract than the upper respiratory tract. That's why the clinical symptoms of this are predominantly that of a lower respiratory tract infection. The other thing is that ACE2 actually protects against lung injury. And what coronavirus does is downregulate the expression of ACE2, leading to more infection. The other thing is that these receptors have signaling differences, and it turns out that this particular novel coronavirus and this particular receptor lead to overexpression of cytokines and chemokines, another part of the pathophysiology and the mechanism by which this virus kills people. All right, what are the clinical features? Well, I already mentioned the first part. The second part, I think I've made clear too, that these 3 emerged viruses that have infected humans are all adapted to infect lower respiratory cells. That's why they're more complicated illnesses than the other 4. This, you've probably all seen maps like this. This is really surprising. First, when I was in Beijing in '99, I flew back directly from Beijing and had my next breakfast in Minneapolis. It was a 747. There were 500 or so of us on that airplane. And back in '99, there were going to be 2 such flights. So 1,000 people were going to go from Beijing, get off in Minneapolis, and go to 1,000 different places. That airline traffic today is 6-fold higher out of China. Train traffic, twice as high. So it is an unprecedented in human history movement of people and material. And that's why this has the potential to spread so quickly. So the current situation, the actual number as opposed to the order of magnitude is less important. But something over 6,000 cases, almost 1,000 of those have been severe. There's been 132 known deaths. 94 cases are outside of China and is spread across 18 countries. And again, we have no antivirus, we have no vaccines. But in the U.S., we know of 5 cases. There has not been a second-generation case. Why? Hand washing, masks, all the things you know to do. But if you actually do them, they work, and they work really well. This number is an illusion. I guarantee you there are thousands more cases than what's been confirmed. The situation in China is they have inadequate diagnostics, inadequate laboratory facilities, inadequate personnel to carry it out. So who knows how many are actually infected. But we do know that human-to-human transmission is occurring. What we don't know is how efficient. And that turns out to be the major boogeyman in all of this. So CDC has released interim guidance, and I will say I've been a critic of CDC and how they've handled some of the past pandemics. I think they've learned a lot. My personal opinion is that we are very well prepared. CDC has done a stellar job in dealing with this and in trying to help China. So what are the clinical features? Fever and, not surprisingly, given what we talked about, symptoms of lower respiratory illness like cough, shortness of breath, etc., and some sort of epidemiologic link, like being in Wuhan in the last 14 days, or having contact with somebody who was there, or contact with somebody who actually had laboratory-confirmed disease. All right, what do those symptoms look like? We talked about the respiratory symptoms. What is less common, but I don't want you to get fooled, is that they can present with gastrointestinal symptoms, particularly diarrhea. And indeed, for some of you that may have looked at the Lancet or a recent New England Journal article where they've sort of started to categorize some of that, there have been people presenting with diarrhea. In the severe cases, of course, you have pneumonia, which progresses to ARDS, kidney failure, and eventually death. Now, how does this actually compare with SARS? Because I made that mention a couple of times. Well, we have about 6,000 confirmed cases, about 132 deaths. That's a death rate of about 2%. With SARS, we had about 8,000 confirmed cases, about 700 to 800 deaths, and the death rate was about 5-fold higher. So this does not seem to have the lethality at this point in the epidemic that SARS did. It's certainly nowhere near the case fatality rate that MERS had. Now, I've put in red there the things that I want you to focus on this, and this is the case fatality rate. I've mentioned what it is for MERS and SARS, but think back to pandemic influenza. Now, lots of people died, but that's because tens of millions were infected, even though the case fatality rate was about 0.02 to 0.4%. About 10% for SARS, 35% for this, Ebola in excess of 60%. So just to keep this all in perspective, okay? Now, this is just recently been released in the Lancet, and this gives me pause because I'm not buying entirely the line coming out of China about how this outbreak started and who's been involved. And the reason for it is this. So the Chinese reported this at the end of December, saying that there was a cluster of pneumonia cases of unknown etiology. And they said, well, you know, could be a coronavirus. We know that the incubation period is somewhere between 2 or 3 days to as long as 10 days. I'm not buying that because the first identified case actually occurred on the 1st. And oh, by the way, these first cases had no exposure to the market that's being blamed for it. So what is it? No one really knows. Did they eat infected animals? Did they come in contact with somebody who had been at the market? It's just unknown at this point. But if people had symptoms here, back up the incubation, this probably started somewhere in October or November and was just not recognized. And that's typical for any kind of pandemic or epidemic like that. It's just not recognized in the beginning. When you look at hospital admissions, the line that's being used is, well, this has predominantly affected older people or people with significant comorbidities. Well, that's not what the data shows. In fact, the data shows with the initial hospitalizations, the majority of them were people less than 50, something like that. Otherwise healthy people. Why? Maybe we're just seeing an odd distribution of the first cases, but no one really knows. I was explaining to Mark, I'm trying to think of a kind of a word picture for this. To me, this is like those, 1,000-piece jigsaw puzzles. We just don't know how big this jigsaw is. We have a couple of pieces, and we don't even know what's missing in some cases. So it's a black box at this point with a tremendous amount to be learned yet. Now, I like this illustration that came out this week in the New England Journal, because I think it shows pretty elegantly what the issues are in trying to understand this. So if we think of this as a pyramid, the vast majority of cases are almost certainly either asymptomatic or mild. By the way, what's not clear yet is whether these folks who don't have any symptoms, can they actually transmit the disease? My guess is yes, but not very efficiently, because how is it transmitted? And if you're asymptomatic, you're probably not doing that. And then you progress up this pyramid to more severe cases and finally fatal cases. These are likely to come to attention. These are highly unlikely to come to attention. And our ability to detect this decreases when we go from this part of the pyramid to this part of the pyramid. Nobody has the ability to test 11 million residents in Wuhan to really understand the extent of this, right? All right, now think about the disease transmission. The first generation of cases has to occur animal to human. So this is fundamentally a zoonosis, a cross-species event. The second generation is from one infected human to the next. Third generation and beyond is amplification of this infection through the population. So that's why this R0, it's called, this looks like R0, this is the reproduction number. This is a quantification of how infectious or contagious a given pathogen is. So if R0 is less than 1, it means that for every infected person, they infect less than one person. That will die out. Okay? If R0 is equal to 1, each person who's infected infects, on average, one other person. So you can have disease, but you're not going to have an epidemic. If the R0 is greater than 1, then for every person who's infected, they will spread to X number of people, depending on what this is. So the R0 for this coronavirus appears to be somewhere between 1.5 to 2.5, something like that. The case fatality rate I mentioned appears to be about 2 to 4%. We do not yet know the viral mutational rate, another boogeyman in this jigsaw puzzle. This thing could adapt to more efficient infection of human cells and more efficient transmission. We haven't seen that, but that's a possibility. So this is visually what this R0 looks like. And this is somewhere around where we are at this point with this novel coronavirus. For every person infected, they infect on average 3 other people who go on to infect 3 other people. And you can understand this is sort of like compound interest or something. It just grows and grows and grows. Now put the mix of international and domestic live and freshly slaughtered animals and humans together and mix into that unprecedented international travel. Now you begin to understand how this happens. So it really is true that what happened in Wuhan yesterday morning affects us this morning. So we know that human-to-human transmission is occurring. The preliminary R0 estimate I've mentioned. This is more SARS-like. 25% of at least the confirmed cases, you see the bias there, it's the confirmed ones that come to medical attention. So we're not looking at the true denominator here, are reported to be severe. The source is still unknown. Most likely it is an animal reservoir. Genetically, this is a bat coronavirus that is mutated, and the extent of human-to-human transmission is unclear. Now, let me just show you one other piece of work. This is Reed's group. They're estimating that the R naught is closer to 4. And if that's the case, the implication is that 3/4 of these are going to have to be prevented by control measures, or this infection will not stop. It will just keep amplifying through the population. They believe that only 5% of the infections in Wuhan have been identified, and that there are more like 11, 12, up to 14,000 people have actually been infected in Wuhan. They think it will be substantially larger, somewhere around, they're estimating a mean of about 200,000 infections. And then, of course, this will be imported to other countries, if you will, made in China. All right. Now, all of that latter data fits more with what we're seeing, but I'll also share what could also be happening. So this is, as I say, I believe this started more in the October-November time range and just sort of sputtered along. This was identified in the end of, or at least I should say China told the world about it, the end of December. And you have to recognize China's not been very forthcoming in the past. I think they've done better this time, it appears, but we'll see. History will record the truth. And then this happens, okay? This implies a much different R naught, or a massive amount of new testing. Which one is it? This is some of the puzzle pieces that are missing. So how contagious is this? If we look at the R naught, the most transmissible human disease is fear and ignorance, right? You know that from your own experience. After that is the virus that I most commonly study, which is measles, with an R naught of somewhere between 12 and 18. If somebody last night had been in this room with measles, and you walked in this morning and you were not protected against it, you would very likely get infected. That's not the case down here, okay? So this novel virus, somewhere around here, not quite what SARS is or any of these other diseases, and probably a little higher or around the same as Ebola. Now, what do we know about human-to-human transmission? Well, 15 healthcare providers in Wuhan are known to be infected. The Lancet reported a family cluster of 7, and there's now been intra-family transmission in these countries. What does this tell me? Inadequate protection here, just the normal things we know to do, and this is only happening within the family, and no second-generation cases in the U.S. That's because the simple things work, and they work really well. All right, clinical syndromes. I think this is not a surprise to you. There's uncomplicated illness, mild pneumonia, severe pneumonia, which can progress to ARDS, sepsis, and septic shock. You know, you get to this aspect of it, there's very little to do, and the only thing to do is supportive care, but I'll make one comment about that. This gives you an idea. This was published last week in the Lancet. Sorry, I should say it the way they do, the Lancet. And it gives you a sense of, from time of symptom onset, like fever or cough, this is the first 41 patients with pneumonia. Their symptoms became severe enough within 4 to 7 days, as long as 10 days, to have to go to the hospital. Some of those then, 11 of those 41, actually developed ARDS and were admitted to an intensive care unit. So it gives you some sense of the disease. Typical severe case, just to kind of make this a little easier to visualize, is from the onset of symptoms to hospital admission, on average was 7 days. That means there are other people who progressed very rapidly, developed shortness of breath, and developed very severe complicated disease. This is a 60-year-old male, one of these cases, and I think for the physicians in the audience, you'll realize just how severe this is. The interesting thing is, actually I think I have a slide there. Yeah, here's the CT scans, and you see sort of this ground glass opacities throughout the lungs. The interesting thing is that this has been seen in people who are asymptomatic with this infection. Not to this extent, but still have opacities like that, and yet are asymptomatic. So it's interesting. People, based on their own genetics, control this disease differently. All right, some significant clinical issues. One, what is the actual incubation period? The longer this is, and if there's asymptomatic transmission, the worse for the world. So we're hoping this really is a shorter incubation period, and this isn't very efficient. Are there going to turn out to be super spreaders? Answer is, based on history, yes, there will be. They could present with upper respiratory infections. Now, this is a real problem, as all of the clinicians in the room recognize, because that's what you're seeing right now. You're seeing a lot of people with upper respiratory and even lower respiratory symptoms. So how are you going to distinguish something that I ought to be worried about from something I'm not worried about? Well, I think shortness of breath is one of those distinguishing symptoms. Certainly if somebody's not improving and they're developing fever and cough and shortness of breath, that ought to just raise in your mind, are they developing lower respiratory tract infection, probably from influenza at this point in this geographic location, but you don't know. GI symptoms associated with that would increase my index of suspicion. Certainly severe disease would too. Clinical management is fundamentally this: supportive care. Now with ARDS, some might be tempted to use corticosteroids. And the lesson learned with SARS and MERS is this was unhelpful and actually delayed viral clearance. So that may be a battle that the ID people are going to have with the pulmonary and ICU folks who are going to want to be given corticosteroids. And that does not appear to be helpful. We should really think carefully about that and not reflex. Certainly antibiotics for bacterial co-infections. This is not unlike influenza, where complicated disease often leads to staph or strep pneumoniae infection. Protecting others and contact tracing and case reporting. That is the hallmark of 21st century management of these cases at this point. All right, how do healthcare providers protect themselves? Well, CDC has released some interim guidance. Of course, any suspected patient, you put a mask on them right away. For healthcare personnel, standard precautions, contact precautions, airborne precautions, and eye protection are what's appropriate. And it works. It works perfectly. We just have to do it well. So how about the wearing a face mask? So we just got back from Washington, D.C. yesterday. I wondered if I'd see a lot of people with face masks, and we didn't. Maybe one or two, but not many. Now, we weren't going to an airport where there were direct flights from China. But does a surgical mask help? I get asked this all the time. And my answer is, well, maybe. Certainly if you're protected, it protects others to some degree. But does it actually protect you? And I guess I would say this: yes, in terms of large respiratory droplets, there's some protection there. But here's what I think the real value of it is. I wish we could have maybe filmed a small group of you, but I'm attuned to it, and I've noticed how often you're putting your hands on your face. You're rubbing your eyes, your nose, or getting something out of your tooth. I don't know what it is. You're touching your face a lot, and it turns out that people do that about 5 to 15 times a minute. Okay? Now, others of you weren't because you're absolutely enthralled with what information I'm giving you. But this, I think, serves as a memory aid, right? It's cough etiquette. You're not coughing into your hand and then touching people and things around you. But if you're really going to protect yourself, you're worried about aerosolized virus, and that's an N95 or greater mask. All right, what works, as I mentioned, all of these things help. Now, hand washing, you would think that healthcare workers would be among the best at hand washing. And unfortunately, that's not what the data shows. The data shows that we're generally as bad as lay people with doing it. I'm not going to show it today, but a couple of years ago, if you've heard of Jimmy Kimmel, he called and asked would I come on his show, and I did. And we did a little segment on proper hand washing. So if you go to YouTube, not now, but later, and you search for Dr. Pollan and Jimmy Kimmel, you'll see a little 4-minute, I think it is, skit that we did. It's pretty funny, but also very educational on how to properly wash your hands. But let me just again emphasize, this is low-tech, high-efficacy, and it stops SARS. All right, some cultural and human factors. Where did these viruses come from? Well, we have to recognize in the last couple of decades, it's been China where these emerging viral diseases have been detected. Avian influenza in '97, SARS in 2003, SFTS in 2010, now this novel coronavirus. And I will dogmatically, in fact, I'll stake my reputation on it. We will see more of this coming out of China. And here's why. These so-called wet markets. So these are mixes of bird, reptile, mammalian species in a very highly stressed environment. You can't imagine the stink, the smell, the crowding in these markets. I, on the one hand, was repelled, and on the other hand, scientifically fascinated. And I couldn't help it. I went in there. And fortunately didn't get sick. But these are domestic and international exotic animals. The Chinese believe that freshly slaughtered meat has a variety of nutritional and then other benefits like fertility, potency, and just some odd cultural foundations around that thinking. And so they import some exotic animals. What did I see? Wolf pups, foxes, rats, peacocks, crocodiles, salamanders, snakes, porcupines, bats, camel meat. I mean, almost anything you could think of, even though it's not found in that part of the world, gets imported there and is eaten. Let me show you some pictures here. So these are fish just being slaughtered on the ground there. What you don't notice is ice. What you don't notice is any kind of facility to wash your hands or wash the ground down. They slaughter geese and chickens, and they just lay out there until somebody buys them. It could be days. You get a sense of how crowded they are. They'll take a pig, and there are live pigs there that are highly stressed. That's important in terms of immunocompromise of the animal species. Slaughter them, and those sit there for days until they're sold. Civet cats, puppies, cats. These are ducks pooping down into a cage where there are chickens because it's a free source of nitrogen. So it's no wonder that stuff like this spreads. This is a guy sleeping on top of all of this. Bats. This is a water buffalo head. And snakes. And, you know, I'll go sushi, but I draw the line there. So the cultural issues is a massive trade in unregulated exotic animals, ingestion of those, very poor hygiene and food protection measures. These are open air and unregulated, never saw ice or any kind of refrigeration or hand washing facilities there. Some of you may have seen this, it's been circulating, but here's an example of culturally. This is a delicacy. I forgot the name of this particular bat, but this is bat soup. And what's particularly good is the soup that is in the belly here. That's what you give your guest, okay? Anybody interested in? No. All right. What about travel? So CDC has upped their travel advisory to level 3, which is, don't go to China unless you absolutely have to go. WHO upped their risk assessment in China to very high and for the rest of the world high. I mentioned this already, but I went online and actually counted this stuff up. That's what you do when you prepare for a talk like this. Between January 20 and 27, 2,300 flights were planned from Wuhan. 2,000 domestically, 200 internationally. That's a 6-fold increase since SARS. And of course, last Saturday, the Lunar New Year started, Year of the Rat, right? Hundreds of millions were expected to travel. Now, the Chinese have sort of tried to lock things down. They first quarantined the city of Wuhan, which is 11 million people. The best estimate is 5 million people successfully ignored that quarantine and are out and about in the world. The other issues, we have an insufficient supply in China of public health infrastructure, of healthcare providers, of facilities. Some of you may have seen China intends to build 2 1,000-bed hospitals inside of 6 to 10 days. They are not hospitals the way we think of hospitals, okay? An insufficient supply of diagnostic assays, of isolation gowns, of all the things you need for proper protection, of IV fluids, and an insufficient supply of transparency. All right, what about international public health issues? And then we'll wrap up here. So this has been quite controversial. WHO is the only entity that has the power to declare what is called a public health emergency of international concern. Okay? The criteria to do that are it has to be an extraordinary event, that is one that's serious, sudden, unusual, or unexpected. So it doesn't have to be an infectious disease, right? A radiation incident, chemical release that somehow would be widespread would qualify. There has to be a risk to other countries, international spread, requiring a coordinated international response. Now here's the key. To declare that presupposes compliance with the regulation, which is that these 192 member WHO countries have the ability to detect, assess, and report to these events. Unbelievably, in the second decade of the 21st century, only about a third of countries have that capability. The other political side of the coin is what it does to a country. With SARS, China lost about 80 billion US in income. Who knows what that number would be now? So there's a lot of pressure to not do that politically. Quarantine, I think, as all of you realize, at the country or population level is impractical. It just doesn't work. What does work is isolation, and this is essential at the individual level. We need increasingly defined case definitions, and what we badly need, and again, as clinicians, you recognize this, is point-of-care assays. Right now, what we do is CDC did develop a diagnostic assay admirably quickly, but you're sending a specimen off, and you might hear a week or longer later. What good does that do? We really need point-of-care assays. All right, antivirals and vaccines. I think you all realize none are licensed. There are a variety of broad-spectrum antivirals that are useful in other viral disease. These are being tested. They've shown activity in animal models against MERS and some of them with SARS. Monoclonal antibody approaches are being thought of, and approaches that were actually used in the 1918 pandemic, which is to find people who have recovered from documented infection and passively give others antibody collected from them. There are no vaccines licensed. One of the problems is the uncertain regulatory pathway. What do you do when there's not an established animal model? Now, it does turn out that non-human primates and ferrets, actually, but not mice, are pretty good animal models for coronaviruses. But you'd like to, I shouldn't say it that way, it is best studied in the context of continuing outbreaks, and that's unlikely to occur. That's what held up Ebola vaccine testing, for example. All kinds of approaches have been used. Messenger RNA, viral vectors, live whole virus and activated virus, recombinant nanoparticle approaches. This is what my group is doing. We've done it with Zika, we've done it with smallpox, we've done it with measles, is we actually infect human cells with either a protein or some other construct. In this case, it would be the S protein. Allow those cells to naturally process and present viral particles in the context of HLA. And we spent about a decade perfecting a mass spectrometry technique to pull those viral particles off of antigen-presenting cells, catalog them, and then use those as the actual antigens of the vaccine. The best guess here, despite what my friend Tony Fauci gets up in front of the press and says, is no, there will not be a vaccine in months. There will not be. There is likely not going to be a vaccine in time for this outbreak. The vaccine approaches are for the next outbreak. So it'll be months before a phase 1 study occurs and years before a vaccine is licensed. What's my evidence for that? Well, many started on developing a SARS vaccine in 2002. It's now 2020, and we have no licensed vaccine. I mentioned S protein is the major antigenic determinant responsible for introducing host immune responses, and antibody to this S protein is what blocks viral binding and fusion. So if you can prevent that, you prevent viral entry into the host cells, you prevent infection. These you might have seen in the news. I think my point in showing this to you is these were being developed in 2002. We've learned from that, and we'll leverage that learning into being able to develop things faster, but it still takes time. I do want to make one point. Of the 5 leading SARS vaccine candidates, in animal models, they did protect mice and ferrets against infection, but something unexpected happened, and that is a type 2 hypersensitivity pulmonary immunopathology was seen. We do not understand why, or even the mechanism for how that happened. So, what good does it do to prevent a disease only to cause a different disease? So this has caused a lot of pause in the vaccine community. Some of you may remember the story way back with the inactivated RSV and inactivated measles vaccine that led to enhanced disease after exposure. This is a similar story to that. There's a lot of development issues that are being considered. We have issues in the elderly because they're immunosenescent, in kids because they're immature. What about pregnant females? For most respiratory viral diseases like influenza is a lethal disease to a pregnant woman, or can be. And this is likely going to be true for these novel viruses too. Which animal model? We don't have a correlative protection. Are human challenge studies a possibility? At this point, no. What would be the duration of immunity of such a vaccine? So a lot of unknowns. So where do we end up here? Critical questions. Will viral mutations occur, particularly when there's widespread infection in virgin populations? Are we going to see antibody-enhanced disease or pulmonary immunopathology? And I'm going to use a kind of a well-worn line. It's not if, it's when here. When will a mutated coronavirus actually cause a lethal pandemic? It will come. It absolutely will come. We've been increasingly following coronavirus viral mutation, and it has happened, particularly in the beta coronaviruses. Well, I started with Camus, let me end with him. Everybody knows that pestilences have a way of recurring in the world. We've seen this. Yet somehow we find it hard as humans to believe in ones that crash down on our heads from a blue sky. There have been as many plagues as wars in history, and yet always plagues and wars take people equally by surprise. So I'll leave you with my 2 rules for success in managing things like this. Number 1, never tell everything you know.